All right, now we're going to go ahead and take a look at graphing these parabolas with Desmos. And you can see I've already set up several on the left side. And first off, the one that you can see is the parent function. And I've made it a dashed line. And you can see it up here on the upper left. F of x is equal to x squared. That's the parent function. Okay? And I'm actually going to change a letter here. I'm going to make this I for later. All right. Now, on any of these, if you're using Desmos and you want to type them in, first off, you don't have to put the function notation using the letters. You could also just say y is equal to whatever it is you want to graph. So that would work. Now, if you want to know what the points are, you click on the Edit List button, like so, and then the first option here that you can see says Convert to Table. Click on that, and you can see the table that creates, in this case, the parent function. And if you want to label them, you would just click on each of these points, and they would come up. Okay, so you can see 5 points, including the vertex at the bottom, and the axis of symmetry would be right in the middle, and it would be x is equal to 0. All right, now I want to go ahead and I want to see if it's going to let me do that. It did. Okay, so I want to just get rid of that. So next up, in class, or in the previous video, I guess, we added in what happens if you have a number bigger than a 1. So I already have one already pre-made, and that's this green one. So I type that in, so 2x squared. Notice it is more narrow, so this has been stretched vertically. It's a vertical stretch, so it's not as wide. And if you want to see the points there, same thing. You can open this up, and I'm not really sure why that is not working right there. That is a little strange to me. You defined G in more than one place. Oh, okay, so I guess it doesn't want me using the same letters multiple times. So maybe if I change that. So let's try J. Yeah, now that works. So that was news to me there. So that's my only H. So I'll make this a K. All right. So now it works. So you can see the points in here. And if you wanted them all in, you would just have to I think you should be able to do this. Yeah. So, yeah, you can go ahead and put in the points like this. Okay. So most of the times you're probably not going to want to click on here to give the points, but there they are. Okay. Now the other one I wanted to show was what happens if you have a fraction. So that's the one I did with the H, and I did this one in purple. So there it is on the outside, and I will put up, well, you know how to do the points. It's the table. All right, so those are examples of positive A's. The purple one, and I'm not sure why it didn't disappear. Oh, it's because of this right here, probably. There it goes. I'm going to get rid of the table just to make that easier to see. So once again, here's the parent function. Here is a bigger number than 1 out front. It makes it less wide, so it's more narrow. And then the smaller number out front makes it wider. All right. Well, now let's go ahead and compare what happens if you flip the function. So I'm going to actually zoom out a little bit and drag this up because I'll go about like this. So I'm going to first turn on that one. So the only difference between these two is a negative out front. So we reflect it across the x-axis. Okay, so that's what's happening right there. And it's not being stretched or shrunk. It's the same thing. So you can leave the original parent on if you want, or leave it off. Then I did put in, I think in the book we did a -1/3. So here is the negative 1/3, and that would be a shrunk one, so it's wider, and then here is a stretched one. Okay, so those are the examples that I wanted to show you here. I will do one more video